So we're going to take some time and review our parent function transformations. And so for our transformation rules, there are vertical and horizontal shifts, up, down, right, and left. You've already looked at them, some of you in your conics unit, and others of you are doing this part first. And you can reflect something over the x-axis or y-axis, and you could have a vertical stretch or vertical shrink. So I just wanted to practice with absolute value and the quadratic, how to write a function with a transformation. And then you are going to complete the 6 problems on the back today as guided practice using your parent functions and just transforming them if they've been stretched or moved right or left. So first, if you want to move up, you add the value outside of the function. So for example, the absolute value of x, let's say plus 8, or x squared plus 8. So you're adding the 8 outside the function. Just like if you want to go down 8. If you want to go down 8, you subtract the 8 outside the function. So absolute value of x minus 8, or x squared minus 8. So the right and the lefts, I think we have kind of reviewed them a little bit, but they're opposite of what you would think. So if you want to shift the absolute value function to the right, you would say x minus 3 goes to the right. And x minus 3 squared goes to the right. And it may seem kind of tricky. Why is it to the right or left? But if you think about plugging in a point, like if I plug in 3 for x, 3 minus 3 is 0. So if the original absolute value function starts at 0, 0, and the point 3, 0 lies on the graph, I think you can see that it's shifted to the right. And if I want to go to the left by 3, I would add 3, so x plus 3 squared. And same thing, if you plug in negative 3, don't you get negative 3, 0? So the graph has moved to the left. Reflecting something over the x-axis or y-axis. So x-axis is like our concavity that's going downward. So I would put a negative sign outside of the absolute value function or in front of the x squared function. So that makes it concave down or flips it upside down. If you want to reflect over the y-axis, you actually put the negative sign in front of the x itself inside kind of a parentheses. So neither of these graphs are going to actually show any reflection because if you already have an absolute value graph, if you take all the negative x values and they go over here, and then all the positive x values go over here, you basically just highlight the same graph on top of itself. So anything that has y-axis symmetry, you're not going to see these reflections. But if you take a square root graph, so like y equals the square root of x, right? That goes this direction. So we know that there's a domain restriction. You can't have any negative values for x. Well, if your function is now negative x inside, now you actually want these negative x values because a negative negative becomes a positive. So it does reflect that graph over the y-axis because all the x values that have been positive are now negative and vice versa. And the last one is stretching a function, so making it taller. So for example, 2 times the absolute value of x and 2 times x squared. It makes it steeper than the original function. And shrinking it would be like a fraction, 1/3 the absolute value of x or 1/3 x squared, right? It makes it less steep. And sometimes you might see a function that's like y equals negative 4 absolute value of x. That's still considered a stretch. So the 4 is stretching the function. The negative sign is just flipping it upside down. So you might have a combination of a couple of these. So now you're going to take a few minutes on your own and try 1 through 6 as practice, dotting the key points. What I would do first, for example, on graph 1, I would graph the key points for x cubed. Do your best. I know the graphs are pretty faint, but then shift all of those, whatever this is telling you to do, left to or up to or flipping it. So I would dot the parent function in on each of these axes for practice and then do the transformation. And then you're taking a picture of this page to submit on Google Classroom. Thank you.